Hello, today we're going to start section 4.3, one variable linear rational equations. Objectives. Use the least common denominator to clear the denominators in a rational equation. Solve one variable linear rational equations and check for extraneous potential solutions. Understand and explain the drawbacks of using a larger common denominator. Part 1. Clearing denominators in an equation. Recall, we solve an equation by iteratively applying inverse operations to both sides. So, for an equation with fractions, or the division operation, since fractions are just division, we begin by multiplying. We call this clearing the denominators. Find the LCD, multiply both sides of the equation by this LCD. As needed, use the distributive property to separate the multiplication to each term. Evaluate and simplify each separate term's multiplication operation. Example 1. Clear the denominators of the following equations. We don't need to solve, just clear the denominators. So for the first one, there is only one denominator, so I'm going to multiply by 4. So when we multiply by 4, the 4 cancels out on the left-hand side, and we get x equals negative 20. Now for the second example, again, there is still only one denominator, so we multiply by 3. Remember, when you multiply by 3, you have to multiply the entire side by 3. So on the left-hand side, we get 3 times 2x over 3 minus 3 times 1 equals 3 times 8. So then the 3 cancels out with the fraction. We're left with 2x minus 3 equals 24. Now there's no more fraction. 2 over 5x plus 4 equals 3 over 2. Well, first we need to do is find the LCD. The LCD here will be 10x. So I multiply everything by 10x. So we get 10x times 2 over 5x plus 10x times 4 equals 10x times 3 over 2. So for the first term, the x's cancel out, and the 5 reduces the 10 to a 2, and then 2 times 2 is 4. 10x times 4 is 40x. And then for the third term, the 2 reduces the 10 to a 5, but the x does not cancel out this time, so we have 5x times 3, which is 15x. And again, we got rid of the denominators. Okay, now the last one, the LCD, is 5x. So we multiply both sides by 5x. The x cancels out on the left-hand side, and the 5 cancels out on the right-hand side. So we're left with 15 equals 4x. Part 2, solving rational equations in one variable. A rational expression is an expression with at least one fraction which includes a variable. A rational equation includes a rational expression on at least one side. In fact, all 4 preceding examples are rational equations. Recall, solving an equation means finding all the values that make the equation true when substituted for the variable. We must be careful when solving rational equations. When we multiply both sides by the LCD to clear denominators, we sometimes introduce new solutions by accident. Such extra solutions fail to make the original equation true and are therefore called extraneous. These are not actual solutions. Example 2. Determine if each potential solution is valid or extraneous for the associated equations. X equals 0 for x over 5 equals 0. Well, 0 over 5, does that equal 0? Well, 0 divided by 5 is 0. So this one is a solution. X equals 0 for 5 over x equals 97. Well, 5 over 0, does that equal 97? Well, 5 over 0 is undefined, so that does not equal 97. So here is an extraneous solution. X equals 3 for 3 over x minus 1 equals 0. So does 3 over 3 minus 1 equal 0? 3 over 3 is 1. 1 minus 1 is 0. So yes, it does equal 0. So this one is a solution. And then x equals 2 for 1 over x minus 2 minus 1 equals 1 over 4. So we get 1 over 2 minus 1. Does that equal 1/4? Well, 2 minus 2 is 0. 1 over 0 is undefined. Undefined minus 1 is still undefined. So we get undefined, which does not equal 1/4. So this is extraneous. How to solve a rational equation. Clear the denominators. Solve the resulting equation by isolating the variable. Substitute each possible solution into the original equation to determine if it is a valid solution or an extraneous one. Example 3. Solve the following rational equations in one variable. Well, there's only one denominator for the first one. It's 5, so I multiply both sides by 5. The 5 cancels out. And we're left with x equals negative 20. Plug negative 20 back in. Does that equal negative 4? Well, negative 20 divided by 4 is negative 4. So x equals negative 20 is a solution. Next one. Again, there's only one denominator, so I'm going to multiply by 4. Remember, you have to distribute it. So we get 4 times 3x over 4 minus 4 times 1 equals 4 times 2. The 4 cancels out in the fraction, leaving us with 3x. 4 times 1 is 4. 4 times 2 is 8. Add 4, add 4. 3x equals 12. Divide by 3, divide by 3. X equals 4. Don't forget, you do have to check, make sure it's not extraneous. So 3 times 4 over 4 minus 1. Does that equal 2? 3 times 4 is 12. 12 over 4 is 3. 3 minus 1 is 2. So yes, it does equal 2. So x equals 4 is our solution. Okay, next one. There's two denominators now, so I need to find the LCD. The LCD between 7 and 2 is 14. So multiplying everything by 14. Then we distribute. Then we reduce. And get 4x plus 28 equals 21. Subtract 28 from both sides. 4x equals negative 7. Divide by 4. Divide by 4. X equals negative 7/4. Now let me move all this over a little bit so we have enough room to check our work. So we need to plug -7/4 in for x. So 2 times -7/4 over 7 plus 2. Does that equal 3/2? Well, here the 2 reduces the 4 to a 2. So we get -7/2 over 7 plus 2. That's -7/2 times 1/7 plus 2. The 7's cancel out. We get -1/2 plus 2. But since I need to add it to -1/2, 2 is the same thing as 4/2. And then -1/2 plus 4/2 is 3/2. So it does check out. X equals -7/4 is our solution. Okay. Kind of went into the next problem a little bit with that one. Okay, next, 5/x equals 2/5. Well, the LCD here is 5x. So I multiply both sides by 5x. On the left-hand side, the x's cancel out, and on the right-hand side, the 5's cancel out. So we're left with 25 equals 2x, divide by 2, divide by 2, x equals 25/2. So we get 5/25/2. Does that equal 2/5? Well, that's 5 times 2/25. The 5 reduces the 25 to a 5. So we get 2/5 does equal 2/5. Okay. 2/x plus 2 equals 1/x plus 5. Now we haven't found an LCD for these kind yet, but x plus 2 and x plus 5, they have an x in common, but because it's being added, it's not a factor. So the LCD here is just multiplying the two denominators together. So I multiply by x plus 2 and x plus 5 on both sides. So on the left-hand side, the x plus 2's cancel out, and on the right-hand side, the x plus 5's cancel out. So we get 2x plus 5 equals 1 times x plus 2, which gives us 2x plus 10 equals x plus 2. Subtract x from both sides and subtract 10 from both sides. That way the 10's cancel out and the x's cancel out, and we're left with 2x minus x, which is x, and 2 minus 10 is -8. So we're left with x equals -8. I still have to check it. Does 2/8 plus 2 equal 1/8 plus 3? Sorry, plus 5. So that's 2/6. Does that equal 1/3? 1/3? Yes, that equals 1/3. So x equals -8 is our answer. Last one for this video. Our two denominators are 3x and 6x, so the LCD is 6x. So I multiply everything by 6x. We get 6x times -8/3x minus 6x times 5/6x equals 6x times 2. The 3x cancels the 6x to a 2, and the 6x cancels out the 6x for the second term. So we get -16 minus 5 equals 12x, which is -21 equals 12x. Divide by 12, divide by 12. That can be reduced by 3, so we get -7/4 equals x. This one I will leave as an exercise for you to confirm that it's not an extraneous solution. And that is it for section 4.3.